Hello, welcome to another video that I'm doing. It's not gonna be long. We're just gonna talk about something you've all seen before, and that is slope. Well, slope and rate of change. Actually, I'd like to change something here. What I'd like to change is this word right here, because I like to say slope is rate of change. The reason why I say that is they're going to give you, now what you understand slope is this rise over run, change in y over change in x. Matter of fact, forget all that crap. You see it as just rise over run, but if you look at it, change in y over the change in x, it's just the rate of change. In other words, how fast is something changing upward, or how fast something's changing downward is pretty much what slope is. So like say this line right here, the rate of change in this line or whatever, like, is the height changing up or is the height changing down? Is it steep? Is it getting steeper? Is it going up? Like, well, not necessarily steeper, but is it increasing? And at what rate it's increasing? So for the most part, you have slope by just doing rise over run. In other words, just the rate of change. I'll give you some classifications of slope here that we probably can understand. For example, it says the slope of a line indicates whether a line rises from left to right or falls from left to right. In other words, it's change in position, if you will. Positive slope, rise from left to right, right? You can have that case. Negative slope, descends from left to right. You can have that case. This is the one people have trouble with, is if you are horizontal. In other words, you are not increasing, you are not rising, you're just flat, you have zero slope. In other words, yeah, well, zero slope. However, if you are completely vertical, like this one right here, you have no slope. You're just going straight down, you're in free fall. So that's the ones that, so it's, well, I should say it's important to understand the difference between those two. Simple problem, we'll deal with the simple problem right now. And that simple problem that we'll deal with, this one right here, a skateboard ramp has a rise of 15 inches and a run of 54 inches. What is the slope? So basically it's rising 15 for every time it runs 54 inches, right? And they ask for the slope. So if slope equals rise over run, then you know how much you're rising. You have 15, right? And you're running 54. Pretty much that'll be somewhat your slope. However, this can be reduced. I like to reduce old school. This is 3 times 5, and this is 3 times 18. Cross that out. Your slope is 5/18. So the way to find slope, finding slope is not bad. In a problem like this especially, it's when you have a graph that things get real. So if I ask you what the slope is of a line passing through those 2 points, right? First off, -1, 3. I know we've graphed before, so we kind of know how to plot points. That point negative, well, no, that's not -1, 3. Don't listen, don't tell nobody. Here, -1, 3, and 2, -1. Those 2 points. So really you're trying to find the slope of that line. Well, really a line that passes through those 2 points. So really how we can find this just by looking at the graph is how much are you rising, how much are you running. Now, since this line is falling from left to right, this has a negative slope. In other words, it's going downhill, going from left to right, right? So let's just find out how much are we changed, like how steep is the slope. To get to the next point, all the way, I went down 4, right? And then over 3. So if that's the case, I know that my slope, being rise over run, being that it's rise over run, I went down 4. So if I went down 4, I kind of went negative 4. And I went to the right 3, right? So my slope, just being 4/3. Now, that's graphically how we can see that slope. If you did this algebraically, you should see it the same way. Remember, y is equal to the change in y, or rise over run, the change in y over the change in x. Now, all this is right here is the Greek letter delta. What delta means is change, right? So if you're trying to find that, you guys have seen the formula for slope is pretty much just y2 minus y1 over x2 minus x1. Now here's the thing, we're given 2 points. We're given this point and this point. Ideally, if I want to find out which ones I want to use, let's say this point right here, point number 1, has an x1, y1. Point number 2 has an x2, y2. I'll call this point 2. So if that's the case, we can just start filling that stuff in, right? So if we start filling that stuff in, for y2 we had -1, y1 we had 3, so -1 minus 3, over x2, which is 2, and x1, which is -1 minus -1. If I try to find out -1 minus 3, -4, and then 2 minus -1 is the same thing as what do you guys say, keep switch change or something like that? That's 2 plus 1, which is going to be 3. Notice we ended up with the same exact slope. So you can do it graphically or algebraically. Now, if you have parallel or perpendicular lines, that says something about the slope as well. So if lines are parallel, first off, they do not intersect. Parallel lines kind of look like that, well, something like that. Lines are perpendicular, if they intersect to form a right angle, kind of like that, right? So here's the thing, when lines are parallel, 2 lines are parallel, they have the same slope. That's all you need to know. If you look at this line right here, say for example the slope for this line right here would be the same slope for this line. So if this slope is equal to 4, that slope is equal to 4. That's what it means by saying m1 equals m2. If lines are perpendicular, they have opposite reciprocal slopes. What I mean is, say for example this slope right here, I'll say this slope right here, I'll say is 2. Now if the slope, that slope is 2, then the slope of this line right here would be -1/2. In other words, I flip the 2 and I make it negative. That's what I mean by opposite reciprocal. So if we're given these problems, we can figure this out, whether or not the lines are parallel or perpendicular, by finding the slope. So how about this? What I want you to do is part A. I want you to pause the video, find the slope of line 1, and find the slope for line 2. And then we'll be able to find out whether or not the slopes are the same. So go ahead and pause the video, find the slopes, and then we'll be able to discuss it when you come back. Now, notice that when I found the slopes, notice the slope of this line was -3/2. And the slope of this line was 2/3, right? So from here, the relationship between those two is you take -3/2, you flip it, make it negative, you get 2/3, right? So because of that, the lines that run through those points are perpendicular. I hope I spelled this right, right? I'll give you another example. This one over here, what you can see here is the slope for line 1 was -5/3. Slope for line 2 was also -5/3. So they have the same slope. So since they have the same slope, these lines are parallel. So you kind of can see how we can calculate slope just given the points, and we'll deal with that soon. Now let's represent slope as rate of change. Just like how I said slope is rate of change, but that's pretty much how we can do it. Here we use a diagram which illustrates the growth of a giant sequoia to find the average rate of change in the diameter of the sequoia over time, then predict the sequoia's diameter in 2065. We can do that because we're given enough information. In 1965, the diameter was 137 inches. 2005, the diameter was 141 inches. So that's enough data for us to find the slope. What if we turn that into points, right? Like say from this table, right? In this table, if I go year, diameter, right? I can figure some things out. So say from here you have 1965. In 1965, the diameter was 137 inches. In 2005, the diameter was 141 inches. So why don't I just make points out of that, right? Matter of fact, let me take this and move it down. Now, since I got this now, I can make points out of those. So say just like you have all points on a graph look like this, right? So you have your x, you have your y. So why can't I make points out of that? How about 1965, right? 137, that's 1 point. And my next point being 2005, 141. So if those are my 2 points, I can find out what my slope is, right? With my slope, let's see, being y1, y2 minus y1 over x2 minus x1. Then let's make 1965 x1. No, not x. And let's make 137 x2. Well, I did it again. Let's make this y1. 2005, let's make that x2. Let's make that y2. Let me fix this real quick. Got it. So if I do that and I put it in slope formula, I get 141 minus 137 over 2005 minus 1965. In the top, subtract that. Is that 4? I think that's 4. And then 2005 minus 165 is 40. reduces to 1/10, right? So the average rate of change, my average rate of change is equal to 1/10, right? In other words, 1/10 of an inch per year. If you So we have those parts. We can find our average rate of change, right? Now we can actually predict how far. We can predict the diameter of the sequoia in 2065, right? First, let me say that the average rate of change, is 1/10 of an inch per year. That's the change that it's making, right? So in 2065, first off, in 2065 is 60 years from the last time you know. So you know that's 60 years from now. If it changes at 1/10 of an inch per year, then 1/10 times 60 will give you how many inches it's going to grow, right? Cross that, I get 6 inches. So if it is 141 inches in 2005, in 2065, your diameter will equal, what's that, just 141 plus 6, 147 inches. We will do more of those problems as time goes. Ultimately, I just wanted to get across slope. Hopefully, you guys remember slope, and this won't be as painful. Until then, oh, that's not what I want. We'll deal with it in class.